Hi guys, here's day 2, or sorry, section 9.2, notes. We're on number 12. We've got the graph r equals 3 cosine theta. So going back, our classifying is not added or subtracted to any number. And my angle measure is not a multiple, it's just straight up theta. So this is going to be a circle. All right, and for the circle, let's start by figuring out what is the value of r when we're at 0. So when theta is 0, cosine of 0, back to our unit circle, right? Cosine of 0 would be the x value out here, that's 1. So this is r is equal to 3 times 1, which is 3. So when theta is 0, r is 3. So on my 0 axis, I'm going to go out to 3, and I've got 1 point here. All right, what about when cosine of pi over 2? Now we're up here at this point. Pi over 2 is 0, 1. So my x value at pi over 2 is 0. That makes this guy here 0. It means my radius is 0. And we're here. For pi, the cosine value at pi, well, my x value at pi is negative 1. This guy here is going to be negative 1. 3 times negative 1 is negative 3. So here we are on pi, but we've got a negative number. So instead of coming out here to 3, I'm going to go backwards to 3. And wait, I'm already there again. So we've actually done one full circle and just one pi. So here's my circle. This would be at pi over 2. Here's pi. It go around one more time if I kept going through pi over 2. And then to 2 pi. So it's going to make 2 revolutions of this circle if we went all the way to 2 pi. As far as symmetry goes for this one, if I cut this guy in half along the pi equals theta, theta is equal to pi over 2 axis, and flipped it, it does not look the same over here as it does over here. So we're not symmetrical there. We are symmetrical across the polar axis because this side looks the same as this side if we flipped it down. And then we're not symmetrical about the pole because this piece here would have to flip down here and look the same, but we don't have anything going on down here. My maximum R value, the maximum amount I went out on any of these spikes here is 3. And then my zeros occurred. Remember, we started here at 0, and then we hit the pole at pi over 2. And then this was pi, and then if we kept going, this would be 3 pi over 2. And that's it for number 12. Since that one went pretty quickly, we're going to go ahead and do number 13. All right, for number 13, what's different about 13? This time I've got one trig function, but this time it's 3 theta, not just sine of theta. So for this one, it is not going to be a simple circle. The 3 indicates that it's going to be a rose. And since that 3 is odd, it's going to be exactly 3 petals. It's a 3-petal rose. All right. And so if we wanted to figure out where our zeros are, so when you're doing roses, probably the best way to go next is to figure out where your zeros are, and I'll show you why in a second. So we want to figure out where is this guy equal to 0? And to solve that guy, we'd divide by 5. We get sine 3 theta is equal to 0. And so that is when, where is sine equal to 0? That's when we are at 0 and pi. And that would be if we went one revolution around. But when we have a multiple angle like this, we have to go as many times as it says around the circle. So we had one here at 0, and then at pi. And then so we got 2 pi. Keep going, we're back to 0 at 3 pi. And then at 4 pi. And then one more time around, we get us back to 5 pi. So this is my unit circle that I'm going around, right? And I want to know where is y equal to 0 if I go around 3 times. So starting at 0, y is 0, then pi, 2 pi, that was 1 circle. 3 pi, 4 pi, that's 2 revolutions. 5 pi, 6 pi. Oops, forgot 6 pi. So those are all my zeros. So, but that's for 3 theta. Then if we want to know what angle theta is, we'd have to divide each of these guys by 3. Right? And these are our zeros, so I'm going to go ahead and actually put them down here. 0 divided by 3 would be 0, then pi over 3, 2 pi over 3, 3 pi over 3 is just pi, 4 pi over 3, 5 pi over 3, and then 6 pi over 3 would be 2 pi. All right, those are all our zeros, and so how does that help us? So if I go and I really lightly with my pencil go and say, well, I'm at 0 at each of these places, so I know my graph is not going to cross this line, and it's not going to cross pi over 3, and 2 pi over 3, and then pi, and then 4 pi over 3, and then 5 pi over 3, and then there's 2 pi again. We're not crossing those points, those lines there, because those are our zeros, which means my petals have to go in between there somewhere. If I had a 6-petal rose, I would be done, because I would know exactly where it was crossing at this point. But I don't have a 3-petal rose. So either my petals are here, here, and here, or they're here, here, and here. We got to figure out what that is. So first, let's figure out pi over 6, what is my R value? It's either going to be undefined, oops, 0. So at pi over 6, what is your R value? 5 sine 3 times pi over 6. Well, what happens to 3 times pi over 6? That becomes pi over 2. My y value up here at pi over 2 would be, sine of pi over 2 would be 1. So R is equal to 5. So at pi over 6, we're out here at 1, 2, 3, 4, 5. So at 0, we started at 0, and then we went out pi over 6, and then we're going to go back to 0 at pi over 3. All right, so then my next angle would be up here at pi over 2. So going back and figuring these points out, 3 times pi over 2. Sine of 3 times pi over 2, that's actually down here. Sine of 3 over pi over 2 would be negative 1. 5 times negative 1 is negative 5. So when I am at pi over 2, my y value is negative 5. So there 1, 2, 3, 4, 5. So from here we come down and then go back to 0. All right, the next one would be 5 pi over 6. It's my next halfway point between 0. So if I plug in 5 pi over 6 here, these guys cancel, and I end up with 5 pi over 2. So here's pi over 2 is here, 3 pi over 2, 5 pi over 2 back. Oh no! What is just a way that I can go back and fix that? All that great work. No! There we go. We got back to it. Sorry about that. All right, so we were here at pi over 2. 3 over pi over 2, we go back around. This is going to be 5 pi over 2 here. So when I'm at 5 pi over 2, my sine of 5 pi over 2 is now going to be positive 1 again. 5 times 1 is positive 5. So when my angle measure is 5 pi over 6, my R value is positive 5. So once I got up here to 0, it comes out here, goes back to 0. All right, what happens at 7 pi over 6? Erase this to get a little muddy. 7 times 5 pi, sorry, just kidding. My equation is 3 times 5 pi over 6. Again, the 3 will cancel with the 6 and make it a 2. Sorry about this, guys. 3 times 7 pi over 6, because that's what we're trying to find. We found 5 pi over 6. At 7 pi over 6, we've got the 3 cancels with the 2, and we end up with 7 pi over 2. pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2 is back down here. So sine of 7 pi over 2 would be -1 again. And so my r value at 7 pi over 2, 7 pi over 6 is -5. So when I'm at 7 pi over 6, instead of coming out here to +5, I go back up to -5. And if you notice, that completes my petal here. And so there you go. There's your 3 petal rows. And your graph is the red part and not the purple part. The purple part is just my guiding lines to help me get the width of my petals and to figure out where the petals go. All right, for our symmetry for this one, this guy is not symmetrical about the polar axis because this half does not mirror this half. It is symmetrical about theta equals pi over 2 because this half does mirror this half, but it's not symmetrical about the pole because these guys are not mirrors of each other. My maximum value, the furthest I went out was 5 on any of the spokes. All right, that's it for number 13. I'll try to hit 14 and 15 before I have to leave for the day.